All right, so what we're going to talk about is linear equations, and this is going to be a big review session. So go ahead and grab your notebooks, title up a new page. So we're getting ready to start a new unit, systems of equations, and we're going to need a lot of these skills before we start that unit. So this is the perfect time to go over a review. I am going to give you fair warning. You're going to remember a lot of this. You're going to hear it. You're going to feel like you heard it in Algebra 1. However, what I usually find at the Algebra 2 level is it's difficult for students when I mix all of the concepts together to be able to distinguish what to do, and we also sometimes have trouble in problem-solving situations. So let's start with the basics. We will write all of this down so we've got a really good reference sheet moving forward. But we're going to start by talking about the slope of a line, which is important because it's really the characteristic that sets lines apart from other functions, is that they have a constant slope. And so when we talk about slope, there's 4 different types of slope that we're going to see in the graph of a line. So the first type of slope that we're going to see here is going to be of a line that looks like this, right? That maybe it rises to the right. These kinds of lines have a positive slope. What you're also going to notice about this line is that it has a slope and it has a y-intercept, and which is what makes it have a steepness to it. So this is going to be written in the form y equals mx plus b, where of course your your slope, is greater than 0, okay? And so the next kind of line that we can have is a negative slope. And lines with negative slope are going to fall to the right. So this is going to be a negative slope. And again, we still have this diagonal line, so we can still express this line in the form y equals mx plus b, where of course our m is going to be less than 0. There's still 2 more types of slope. So the next kind of slope that we're going to see is of a horizontal line. And these types of lines have 0 slope. So we want to be careful that we don't say that it has no slope. That is not true. It does have a slope, but the slope is 0. Well, let's also consider the way we write the equations of horizontal lines. Horizontal lines can be expressed as y equals, and it equals some constant number, such as y equals 2 or y equals 3. So let's say this right here would be the line y equals 2. The last kind of line that we have, the last kind of slope that we have, would describe the slope of a vertical line. And vertical lines have an undefined slope that we're going to look at in one of our examples to see why that happens. And so going back to our vertical lines are expressed as x equals equations, okay? And they equal x equals some kind of constant number. And so maybe we say that this is the line x equals 2. So a little review over slope, how to write equations of lines. The next thing is, how do we calculate the slope? So one way to calculate the slope is if I was given a picture, I could find 2 points on the line and I could count up and over, or maybe I could be given 2 points and I could count down and over. But what if I'm not given a picture at all? What if I am given 2 points? And so we can use the slope formula if you are given 2 points. So our slope formula, okay, given 2 points. Say we're given an x sub 1 and a y sub 1 and x sub 2 and y sub 2. And so if I'm given 2 points, we can say that your slope, is equal to y2 minus y1. And so what this does when you subtract is it finds the changes in y's and divides it by the changes in x. Okay, so that right there is our slope formula, which is a good place to work through just a couple of examples. All right, example 1 is going to have a couple parts. We are going to find the slope, okay, given, and we're going to look at a part A and a part B. So for part A, we're going to find the slope given f of negative 1 is equal to 6 and f of negative 5 is equal to negative 4. At any point in this video, if you need to hit the pause key to write down the problem, please feel free to do so. Now, this notation looks a little different than maybe what you saw in Algebra 1. Let's think about function notation and what this means. Sorry about that. This -1 is the input, which is always your x. The 6 is your output, which is the y. So this is really just going to represent the ordered pair -1, 6. Again, the -5 is the x coordinate, the output -4 is the y coordinate, and so what we have is we have two ordered pairs -1, 6 and -5, -4. So we'll get used to seeing that throughout the year written in function notation. Our slope is going to equal, we're going to start by taking y2 minus y1. And it really doesn't matter if you want to take y1 minus y2, you just have to make sure that you subtract in the same order consistently. Okay, so it's going to be -4 minus 6. And then I'm going to have, this is where we need to be careful, it's going to be -5 minus -1. Make sure that we distinguish between the minus and the negative. Well, when I minus the negative, it's going to turn into plus plus. So if I simplify this, I have -10 divided by -5 plus 1, which is 4. You always need to simplify your slope. Well, the first thing I see is a negative divided by a negative is going to be a positive. The second thing I see is both of these are divisible by 2, and so when I simplify this, I get a positive 5/2, and that would be our simplified slope. The slope of this line would go up 5 and go to the right 2, okay? We're going to look at one more. Let's suppose this time we are given the ordered pairs 3, -4, and 3, -2. Let's set this up. Your slope is going to be equal to, again, it's going to be y2 minus y1. So -2 minus -4. And then it's going to be x2 minus x1. And so we see 3 minus 3. All right, minus a negative turns into plus plus, and so what we see right here is 2 divided by 0. Now we can't leave our answer as 2 divided by 0 because we need to distinguish whether this is a positive, negative, 0, or undefined. So leaving it as 2 divided by 0 is too vague. It's not quite finished. All right, well, let's go ahead and pull out our graphing calculators and see what happens when we take 2 divided by 0. I'm going to hit enter, and you can see that I get error overflow. Now, this is a different kind of calculator. Your calculator probably says error divided by 0. But the point is that we get an error. And the reason we get an error is because this is an undefined slope. And that undefined happens because we divide by 0, which you cannot do in math. So I had a student a couple years back, and she showed me this little trick of how she remembers the slope. Okay, this is just a little trick you can use to help you remember about the 0 and where it's allowed to be. She showed me that it is okay to have a 0 in the numerator, but it is a no to put the 0 in the denominator. So if we have 0 divided by a number, we're going to have a slope of 0. But if we have a number divided by 0, this is going to make an undefined slope. So use it if you want. It's just a nice little trick to help keep it straight. The next thing then that we would talk about after talking about slope would be parallel and perpendicular lines, which I feel like you talk about a lot in geometry, but we're going to talk about the algebra of parallel and perpendicular lines. Okay, parallel lines. What's special about parallel lines? Well, they're two lines that never intersect. And why do these lines never intersect? They never intersect because they have the same slope. And so if this line has a slope of, looks pretty steep here, we'll say a slope of 5, then this line would also have a slope of 5. And so if I'm given information about a parallel line, I can then figure out information about the slope of the line. Okay, so what about perpendicular lines? Well, perpendicular lines are going to cross. They are intersecting. But what's special about perpendicular is they not only intersect, but they intersect at 90 degrees. The slopes of perpendicular lines are opposite reciprocals. So one is going to be positive and one is negative, and the other thing we're going to do is flip the fraction. So let's suppose here that this line has a slope of 4. then the slope of this line is going to be a negative, and we're going to flip the 4/1 and make it -1/4. And so what you will find with reciprocals, opposite reciprocals, is when you multiply a number by its opposite reciprocal, you will always end up with -1. So if you ever feel like you can't tell whether or not something's an opposite reciprocal, you can always try that trick right there. All right, let's look at an example. Let's pull together everything we've talked about so far. Example 2. Okay, we're going to write the equation of a line. Perpendicular to the line y equals -3. And it's going to pass through, okay, passing through this given point, -2, 4. All right, take a second to write all of that down. I'm going to reread it here again for myself. We're going to write the equation of a line perpendicular to the line y equals -3, passing through -2, 4. So we really haven't talked about different equations of lines, and that's because we don't need it yet. With this particular problem, we need to think about what type of line y equals -3 is. And the type of line that y equals -3 is, well, let's come back up here, or you can look at your notes. But what we have going on is any y equals line is a horizontal line. Okay? And so what I'm going to do is I'm going to figure this problem out by drawing it rather than using some kind of an equation. So y equals -3 is going to be right down here, okay? It's going to be the horizontal line that crosses the y-axis at -3. Now, what's the given point? The given point is -2, 4. And this is going to be the point -2, 4. So what I'm going to do over here with the red pen is I'm going to draw a line perpendicular that passes through this point. Well, the perpendicular to a horizontal line is going to be a vertical line. And so the equation of this is going to be x equals, because that's what we talked about before. Vertical lines are always x equals. What does x equals? Well, it depends. What point does it pass through on the x-axis? And it passes through -2. So you're going to see little problems like this. They're not terribly difficult, but I think where students get hung up is they try to use an equation to figure it out, where really we just need to use a picture and kind of use our own reasoning to figure this out. So the last part that we're going to talk about are equations of lines. And there's 2 equations that are the most useful. Hopefully they both look familiar to you. Okay, equations of lines. The first one is going to be your slope-intercept form. And this one is the one I feel like most students are comfortable with leaving Algebra 1. This is your y equals mx plus b, where the m is your slope, right? And the b is your y-intercept. This form is good for graphing, okay? It's good for graphing equations of lines. I don't love this form for writing equations of lines because very rarely do I feel like I'm writing the equation of a line where I know the slope and the y-intercept. But it is a good form for graphing, which is why we're always going to solve for y before we graph. The second form is going to be point slope form. And you are going to use this form when you're given a point and a slope. And it looks like this. It's going to go y minus y1 because you're going to plug the y coordinate in, equals the slope m times x minus, and you're going to plug in the x coordinate. When we do our example, we'll talk a little bit more about how to use this form. This form is good for writing. Okay, it's good for writing equations, which may be a little different than what you did coming out of Algebra 1, but the truth of the matter is point slope form is a little bit more usable, and you'll see it much more often when we get to pre-calculus and calculus. All right, let's look at an example. Example 3. All right, this one's a little wordy, so pause it if you need to. Write the equation of a line that is perpendicular to x plus 4y equals 5, such that f of 2 is equal to -3. You go ahead and finish writing that. I'm going to look over and make sure I got everything I need. Write the equation of a line that is perpendicular to x plus 4y equals 5, such that f of 2 equals -3. Here's the big thing you need to keep in mind when you're writing the equations of lines. You need two things, okay? You need a point and you need a slope. That is what you need. I know you want the slope in the y-intercept, but you're not getting the y-intercept. You need a point and you need a slope. Well, I'm given one out of the two. I'm sorry, I checked the wrong thing. I'm given one out of two things that I need. I am given the point. And the point that I'm given is going to be 2, -3. So that's my entry point to this. What do I need to do first? I need to figure out the slope. Okay, so step one, we need to find the perpendicular slope. Okay, well, what I'm given here is I'm given this equation, x plus 4y is equal to 5. We can use this equation to figure out the perpendicular slope. Okay, let's go ahead and let's remember how to solve for y. We get 4y equals -x plus 5. When I divide by 4, we want to divide each part individually by 4. And so what I see here is this is going to be -1/4. So my slope is going to be -1/4 x plus 5/4. I don't recommend writing it as -x divided by 4 because usually then people are confused over what the slope is. Now, what do I care about with this line? What I care about with this line is, I don't care about the y-intercept, it's the slope that I'm looking at. So the perpendicular slope is going to equal the opposite, so it's going to be positive, and it's going to be 4/1, and we can just call that 4. So now, coming up to my little checklist, I needed a point, and I was given it, but now I have the slope, which is 4. So step 2. You are going to use m equals 4 and the point 2, -3 to write the equation in point slope form. Okay, and I know some of you guys like to plug everything into y equals mx plus b and solve for b, but here's why I'm not having you do that. Sometimes the directions tell you to just leave it in point slope form. I would say most of the time in calculus, you just leave it in point slope form. So let's get out of that habit of plugging everything into y equals mx plus b, and let's leave that in algebra 1, okay? So here's how this is going to work. Here's our point slope form. It goes y minus y sub 1 equals m times x minus x sub 1. Well, we're going to start by going y minus, and I'm going to substitute in the y coordinate, which is going to be the -3. And it equals my slope, and I'm going to substitute in 4 for the m, and it's going to go x minus, and my x coordinate right here is going to be 2. So that is how we plug in the slope and plug in the point. Let's go one more step. Y minus -3 is going to be y plus 3. And I have 4 times x minus 2. This right here, this is point slope form. And it is an acceptable way to write the equation of the line, and sometimes I even have you just leave the equation of the line in point slope form. But what's kind of cool about this is if you solve for y, you can write in slope-intercept form by solving for y. So all we need to do is take our equation right here, y plus 3 equals 4 times x minus 2. All we need to do right here is distribute the 4, get the y by itself, and it's going to be in slope-intercept form. So I'm going to minus the 3 from both sides, and we're going to get y equals 4x minus 11. And this right here is going to be slope-intercept form. So I want to make sure you see the difference between the two, and I also want you to see how we use point slope form to get it into slope-intercept form, because there's going to be an activity coming up where that's what you are going to do. Okay, we're going to finish this with one more example. What are we at? Example 4, and maybe this would be even a good point to even pause the video if you need and try it on your own. I want you to write the equation of a line in slope-intercept form. Passing through. Okay, we're going to do the points, let's see, 2, 4, and we're going to do the points, let's say 1, and we'll just put in an 8 right here. Okay, so passing through the points 2, 4, and 1, 8. Okay, so go to your checklist. This is usually the hardest part right here, is like, where do we start? What equation do we begin with? I'm going to make my checklist. Here's what I need to write the equation of a line. I need a slope, and I need a point. I know you want the y-intercept, but you're not getting it, so you're going to have to deal with the slope and the point. Well, the point I'm given, okay? In fact, I'm given 2 points. I'm given 2, 4, and I'm given the point 1, 8. So where do I begin on this problem? I'm going to start by finding the slope. And this time, I don't have a parallel or perpendicular line to use. I'm going to have to use the slope formula. And so the slope is going to be 8y2 minus y1, 8 minus 4, divided by 1 minus 2. So I'm going to keep going, and I get 4 over negative 1. My slope is now negative 4. Step 2, you're going to plug into point slope form. We're not doing that y equals mx plus b stuff anymore, okay? Because if you go up to your checklist, now I know my slope, and this is how I know I'm ready to go, okay? So I've got my slope and I've got my point. So you're going to plug it into point slope form. I don't care which point you use. That's the purpose of this example right here. If you want to use the 0.24, use the 0.24. If somebody else wants to use the 0.18, use the 0.18. I don't care for your notes if you do both the green and the purple. Pick one. Pick the green, pick the purple, plug it into point slope form. This is what it would look like if you use the 0.24. It'd go y minus the y coordinate 4 equals the slope times x minus the x coordinate. And so you can see what I'm doing here is I plugged in this for x, this for y, and this right here is my slope. Let's come over here to the purple. If I plug 1, 8 into point slope form, it's going to go y minus the y coordinate 8 equals the slope times x minus the x coordinate 1. So again, this is my x, this is my y, this is my slope. So they look different. Okay, but what I want to show you right here is that when we distribute and solve for y, we are going to end up with the same thing. Okay, distribute the negative 4. I'm going to add the 4 over, and the slope-intercept form is negative 4x plus 12. Well, let's come over here to the purple, and we get y minus 8. Again, distribute that negative 4. When I add the 8 over, what we see is you end up with the same thing. And so that's why I like ending with that example right there, is whether you use the first point that was given or you use the second point that was given, you're going to see right here that we get the same thing. All right, thank you for tuning into all of that. I know that was a lot of notes, but hopefully it tees you up for the rest of the week to be able to understand these concepts. We'll talk to you next time. Bye.